translational modification, it means we've already made the primary polypeptide sequence, right? We've already attached all the different amino acids together and it's in the right thing. What we do when we change this protein is we go along and we find the glutamic acid, like that's a specific amino acid, maybe it's in position 12, or position 15, or position 45, right? We go find it and we change it. We change it from being glutamic acid to being gamma-carboxy glutamic acid, which is GLAW. What that means is on the gamma carbon, right, CH, we've added, this already was there, one COO minus. We've added a second COO minus. That's the modification. I'm not going to ask you to know the specifics of what that is. Like, you don't have to tell me, you don't have to draw it out or show me the change. But you do need to know it's a post-translational modification, that we change glutamic acid to gamma-carboxy glutamic acid. And that's how this works. By doing this, so calcium 2+ is missing, right? So you've got a 2+. Look at this. Now you have a domain on this amino acid, which is part of a protein, that has 2 minuses in close proximity. So a 2+ thing that's looking for 2 minuses, 2 minus thing, we can put them together. Okay, let's go back to this. There are other vitamin K dependent proteins. They work in the same way, but they're in different areas. They have roles in bone health, in metabolism, and inhibition of incorrect bone formation. Because if you're binding calcium, you need calcium to lay down bone, right? Bone, when you make bone, you're storing calcium, and we'll talk about that after the break. But the idea is that these are involved in making sure you don't do too much of that. Okay, but most of the time we think vitamin K, we think blood clot. So let's do this. So that I want to know. And they do have roles in bone health. Okay, and then roles in cell persistence, but okay. All right. So nomenclature of active vitamin K compounds. That means which ones are you looking at? Which ones do you have to know and where do they come from? So I'll zoom out. All right. This is phyloquinone. This is vitamin K1, and it's our green leafies. This is amenaquinone. There are multiple menaquinones. If you go back to thinking about folate, where you can have multiple domains and you can just multiply them out, it's the same thing here. This is menaquinone 7. What these brackets mean is that this is repeated 6 times. So this is menaquinone 7 because you have it once, but you have to have it. And then you go all the way through, and 1 plus 6 is 7. 1 plus 7 is 8. I will not ask you to count them. You just need to know the difference between phyloquinone and not. So phyloquinone is exactly the same, right? It just happens to have this 3 at the end. So phyloquinone only has 3 of these things, right? And then notice the one other difference is this double bond. Here there is no double bond right here. Here there is a double bond. That's the difference. I'm only going to say, is this the menaquinone or is this phyloquinone? I'm not going to go how many numbers are it. Just this is the bacterial form. Like when we talk about we get our vitamin K from our bacteria, right? It's more nuanced than that, as you'll see in this chapter. But this is because our bacteria produce a ton of menaquinones, our intestinal bacteria. This is your green leafies. Okay, and then there's this third one down here, which is metadione, which is synthetic and added to animal feed. I only want you to know the first two. I want you to know phyloquinone and menaquinone. I want you to know that you've seen metadione, because if you go and you work, if you end up working for the USDA, or you end up working in food science, or you end up working somewhere else, you're going to spend a lot more time with metadione. Okay, but for us, for humans, we're talking about phyloquinone and menaquinone. So just know the difference, and really just look for the double bond. And again, not draw, just recognize. So